denominator equal to 0. And solve. So you remember how to factor? How would I factor this? What can I pull out of it? An x. So our x is going to be our greatest common factor. So then we're left with x to the 4th minus 4 equals 0. Can we factor this further, the x to the 4th minus 4? What do you get?
X squared plus minus 2 plus.
So x squared plus 2 and x squared minus 2. And now we need to set each of these equal to 0 to find our x values. We have x equals 0, x squared plus 2 equal to 0. What would you get?
Square root plus or minus square root 2.
And how about for x squared minus 2?
Plus minus square root 2y.
Hi.
Wait, this one here. This one inside. Okay.
I'm asking you. Okay.
So my domain would be, what's my smallest one?
0. Oh yeah, because it's negative, so it's y.
The negative, right?
Yeah.
So I'm going from negative infinity to negative, it'd be this one, negative square root 2. So we don't pay attention to the irrational numbers. Close this, do union, because we don't include it. Do negative square root of 2 to, what's my next number?
Square root of 0.
0. Union 0 to,
Square root 2.
and I need one more.
Square root 2 to infinity.
Alright, do you guys have any questions on how to do that? So what would my vertical asymptotes be? What is a vertical asymptote?
Where it skips.
So it's where the graph comes really, really close to a point, but it doesn't quite touch it, right? So if I had a graph like this, and say my graph looked like this, so it's coming really close to this value over here, say x equals 5 over here. So 5 would be my vertical asymptote. So if I look at my domain, I'm not touching negative square root of 2. I'm not touching 0 and positive square root of 2. I'm not including them in my domain. So those would be my asymptotes. So I have 0 and plus or minus square root of 2. And make sure it's x equals. Alright, B. What's my first step? I need to set this equal to 0. And now pull out a greatest common factor. What am I pulling out? 2x. So I'm left with x squared plus 1 equals 0. both equal to 0. 2x equals 0, and x squared plus 1 equals 0. So what are my two x's?
0.
And this is an irrational number, so forget about it. Right? You see why it is?
Not irrational, imaginary.
Imaginary. So my only x value that I found was 0, so that's my asymptote. And how would I write my domain?
Negative infinity, comma, 0, union 0, comma, infinity.
Yep. Do you guys have any questions on that one? Alright, so for our next one, we are going to learn about horizontal asymptotes. So it says compare the degree of the numerator n with the degree of the denominator k. So if the degree of the numerator is less than the degree of the denominator, then the x-axis is the horizontal asymptote. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote will be this equation right here. So the leading coefficient of the numerator over the leading coefficient of the denominator. And then, what?
So why is it here? Like italicized, regular italicized? Is like one question?
So it stands out.
Oh,
I
okay.
just did it so it stands out. No reason. Does it stand out? It stood out.
Well, yeah.
Stood out.
Noticed it.
And then in part C, it says if the degree of the numerator is larger than the denominator, then there won't be a horizontal asymptote. But there's two other types of asymptotes that can exist. So we have a slant asymptote. That's when the degree of the numerator is exactly one more than the degree of the denominator. So this would be an example. So you look at this number right here, the numerator is 3 and the bottom one is 2. So that's only one more. And then another example would be if this was x squared and the bottom is x. So the coefficients are 1 apart.
The degree is 1 apart. The degree, not coefficient.
And the second type that can occur is a parabolic asymptote. And that is when the degree of the numerator is exactly 2 or more than the degree of the denominator. So these are two examples. 2x to the 4th minus x plus 4 over 2x plus 1. So the degree of the numerator is 2 more than the degree of the denominator. And same for this one. The degree is 3 in the numerator and the denominator is 1. So that would be 2 more. So we can find the asymptotes by using synthetic or long division and just ignoring the remainder. So let's do a few examples of these. So this first one, I look at my degree is 3 and 3. So what does that tell me? What type of asymptote I'm going to have? A horizontal. So my y would be, my asymptote would be this right here. So it's the leading coefficient of the numerator over the leading coefficient of the denominator. So I would have 5 over 2. Or this is equal to 2.5. So the my numerator?
3,
3, and the bottom is 1, so
parabolic.
parabolic, yes. Since it is, the numerator is 2 more than the denominator. So how would I find my asymptote? I would use synthetic division over here. Do you remember how to do synthetic division? So we're gonna divide the denominator into the numerator. So I'm dividing by what? 1. And what goes inside my box?
1, 0,
1, 0, 2, and negative 1. So bring down the 1. 1 times 1 is 1. Add these. Multiply. Add. Multiply and add. So we are left with y equals 1x squared plus 1x plus 3. So that would be our asymptote. Anyone have any questions? You ignore it. So when you do synthetic or long division, you just ignore the remainder.
Is that it?
And for the third one, look at my degrees. It's 2 on the top and 1 on the bottom.
slant,
So this is a slant since the top is 1 more than the bottom. And how do we solve for these? Yep, use synthetic division again. So I'm going to divide by negative 1 this time. And inside the box, I have 1, 3, and negative 5. I'll bring down the 1, multiply these, add, multiply, and add. So my remainder would be negative 7. We ignore that. And then my asymptote will be y equals x plus 2.
I have a question. What would you do if the denominator was 2x plus 1? What would you do now? There's still a slant asymptote. Long divided. Good answer. Long division. Yeah, right?
Okay, last example. What is the degree of the numerator? 3, and the denominator is, so what type of asymptote is this? Horizontal? And what would my asymptote be? How would I solve it? Remember how to solve these? Y equals 0. Okay, any questions on those ones? Alright, so look at these. So it says there are a few other special parts to consider. The y-intercept. So when you want to find the y-intercept, you need to set x equal to 0 and then solve for y. And that will give you your x-intercept. Or y-intercept. The x-intercepts, or the roots, is when y is equal to 0. So to find those, you set y equal to 0 and solve for your x's. So you look at what makes the numerator equal to 0. This is the only part of the fraction that matters when you want y equal to 0. And sometimes there's holes. So when we example of a whole would be right here. We have f of x equals 2x squared minus 4 over x minus 2. So when we reduce this, we would factor the top and get x minus 2, x plus 2, and that's over x minus 2. These two terms cancel, so you're left with x plus 2. And when you, so this is, since these two are not the same, then we have a problem. 2 makes the denominator 0, and we can't have 0 as a denominator. So whenever 0 is in the denominator, we say that there's a hole in our graph. So to find out where the hole is, we would plug 2 in for x and solve over here. So plug 2 in over here, so 2 plus 2 equals 4. So our hole would be at 2, 4. So whatever makes the denominator equal 0, so x minus 2 equals 0, we would add 2, x equals 2. We would plug this number in over here. It's 4, so that's the y of our hole. Does that make sense? Alright. So critical values are numbers that make both the numerator and the denominator 0. We need to factor the numerator and denominator completely and use the critical value along with all the factors to make an exclusion chart. So we are going to do now. Alright, so we need to graph this. Our critical values or the roots, how do I find them?
You know what, there's a boo-boo on this. But we'll fix it quickly. See where it says CV? There was supposed to be a separate line. Yeah, do you guys mind doing that? I did it on every problem. I typed this up, my fault. You guys are, don't give me that look, because you guys would have to do this by hand in your book. And it doesn't give you all these little cues. Huh? I will, just for you, Jordan.
Okay, critical values. So they're the numbers that make the denominator and the numerator equal to 0. So what number would make the numerator and denominator equal to 0? 0 makes the numerator equal to 0. How about the denominator?
No, it makes negative.
It makes it equal to -3, right?
Hmm?
Does it have to be for both?
Yes, the critical values, yeah.
So that wouldn't work.
Wait, what number?
0.
0 is 1.
You have to make the bottom and the top equal to 0?
No,
Just 1.
both, the bottom and the top. You have to factor the denominator. Factor the denominator. Does everyone know what she's doing right now? She's factoring the denominator. So the critical values are, there's going to be a change in your graph where the numerator and or the denominator is 0. So all your critical values are 0 for the numerator, put a 0. put negative 1/2 and 3. You're gonna use those three numbers. Do you guys see at the bottom of it says exclusion chart? You want me to do this? Your critical values are where the numerator and the denominator not intersect. When I say and, it's where both of these give you a 0. So 0 here, for every x, you're gonna get a 0. 0, negative 1/2, and 3. You are going to use these three numbers right down here. I want you're gonna list all these factors in this little chart. Put an x right here. Put a 2x plus 1 right here, and an x minus 3 here. And at the very bottom, you're gonna write f of x. This is going to tell you how to graph this without a calculator, that f of x. So factor the numerator, factor the denominator. And so you have x, 2x plus 1, and x minus 3. Right here, in these spots, I want you to pretend like you have a number line. And in this number line, how would you order these three numbers? What's the smallest number? Negative 1/2. Put a negative 1/2 right here. So pretend like this is a number line right here. And I set this up for you so it will be easy. So this would be negative 1/2, then right here you're gonna put 0, and then right here you're gonna put a 3. Everyone got me? Okay. What you're gonna do is you are going to fill this up with pluses and minuses. Okay? Pluses and minuses, meaning, pretend like you have a number line here. Pretend like this is an actual number line. If you were to put a number to the left of negative 1 on a number line, or negative 1/2, sorry, like negative 1, what would you get? Would this be a positive or a negative number?
Negative.
Negative. How about if you picked a number between negative 1/2 and 0, like negative 1/4? This would be negative. How about if you picked a number between 0 and 3? I'm going to show you a shortcut too how to do this. 1, let's say you put a 1, this would be a positive. And once you hit a positive, most of the time, there's a few exceptions, but it'll all be positive. Now, here's my shortcut. How do you fill this out quickly? If you were to set 2x plus 1 equals 0, what would x be? If you were to set 2x plus 1 equal to 0, what would x be? Negative 1/2. So this is a quick way I do it. To the left of negative 1/2, that's going to be negative, and these are all going to be positive. You get it? How about this one? If you were to set x minus 3 equal to 0, what's the 0 in this one? 3. So here's 3. These will all give you negatives, but this is going to be positive. You get it? Okay, now, here's where the f of x comes in. What you're going to do is count how many negatives you have in this column. If it's an odd number of negatives, think of when you multiply. If you have 2, it's even, it's positive. You're going to count. There are 3 negatives here, so the grand finale is negative. These are 2 of them. This is going to be positive. This is 1, negative, and positive. This bottom row right here is going to tell you if your graph, so between negative infinity and negative 1, the graph is going to be below the x-axis. Between negative 1/2 and 0, your graph is going to be above the x-axis in the positive region. Between 0 and 3, your graph is going to be below, and between 3 and infinity, it's going to be positive. Okay? So now, let's fill in all these important parts right here. The roots. The roots are where the numerator is equal to 0. Only the numerator. These are the x-intercepts. So look at your numerator, you have an x here. The only root that you have is 0. At this point, I want you to put on the x-axis, you're going to put a solid dot. So your graph has to go through 0. Okay, next thing. Your vertical asymptotes She told you about how to do those. What you do is you set your denominator equal to 0, and you are going to give me the vertical asymptotes. Your graph will never, ever cross a vertical asymptote. Think of it as a fence. You can't go past that. So what are your two vertical asymptotes?
Negative half.
-1/2 and 3. I want you right here, make sure you have x equal. Now at these two places, I want you to go to your graph, and I want you to put a dotted line right here at -1/2. Why do we make it dotted and not solid? Because it's not part of the graph, it's just a guide. So far, so good. So, next, see that, yes,
You said the roots was in place of across the x-axis.
the numerator. Yes, yes, where it crosses the x-axis, yes.
Then how come there's two negative parts of this way? It doesn't have to cross the x-axis.
There's two, wait, say it again?
Like right here, it's that starts negative positive, negative positive. If you
Hang
start
on,
negative.
hang on to your question. Hold on, you'll understand. Hold on. I'm gonna answer in a minute. Okay, which one of these do we have? You're gonna have only one of them. Is it bottom heavy? Is it top heavy? What is this? So we go back to the original. It's bottom heavy. It's bottom heavy. So you're gonna have y equals 0 is your asymptote. That means there is no slant. That means there is no parabolic. You need to make some kind of indication that there isn't one of these. If it were top heavy by 1, there would have been a slant asymptote and not one of these two. If it was top heavy by 2, there would be a parabolic and not one of these two. Now on an application, if it asked you, have you served in the military? Okay, if you received a college application or an application for a job, and it said, how many years of military service do you have? What do? Do you ignore that question and move on?
No.
What do you write?
0.
You have to write something in that line. Same goes here. Every year, I hand this test out, and at those two places, I see nothing. It's blank. That's not acceptable. You need to address the fact that there are no slant or parabolic asymptotes. So write something, NA, not applicable, something. That's,
Zero
I,
with the slash.
0 with a slash through it, okay?
Yeah.
How do you find the y? Oh, let's, by the way, right now, we're gonna graph y equals 0. Now, this is what I do. I go like this. I do a dotted line right here. Okay, now, this is the strange thing with a horizontal asymptote. And I think Jordan is gonna, this is what Jordan's asking. A function can cross a horizontal asymptote. Where is it gonna cross? In the middle. Right around this good stuff right here. It can, and it's going to. See this? This is a horizontal asymptote. A graph will not cross vertical asymptotes, but it can cross a horizontal. Now, what it's more, a horizontal asymptote is more for the end behavior. It's gonna get closer and closer to the x-axis, but it's going to cross right here, and that's where it's a little fuzzy. Is that what you were gonna ask? I think that's what your question was.
Once you finish, I'll
Okay.
answer.
All right, okie dokie. How do you find the y-intercept? She told you how to do this. It's an ordered pair. 0, if you put a 0 here and a 0 here, what's 0 over anything? It's 0, 0, 0, which is what we had. You will only have one y-intercept. Unless, can you think of a way you would not have a y-intercept?
It's not function.
No, not if it's not a function. Anyone know?
It's a horizontal line.
No.
Vertical.
Vertical line?
There you go. If a vertical asymptote was the y-axis, then you won't have a y-intercept. That's the only time you won't have one. It could happen. It could happen. Now, is there a hole? You will only have a hole if you cross out a factor and you lose an x, like a vertical is no hole, so address it, nothing, there is none. Now, this is where the fun begins. Watch what you're gonna do. This is what you're gonna do now. You're gonna draw something in that region. So from negative infinity to negative 1/2, where's negative infinity? Here's negative infinity to negative 1/2. That was our first critical value. Our graph has to be in the negative region. So what you're gonna do is you're gonna just draw something. So pretend like your graph is coming, we don't have to be that accurate, but just go like this. That's your graph. So you wanna stay as close to the asymptotes as you can, but draw something that you're not gonna go over the asymptotes. Now, if we wanted to be accurate, you're gonna take numbers and make a T-chart. We're not gonna go into that detail. Like if we wanted to know exactly how far down this, you might wanna put in -4, -3, -2, -1. Evaluate it. We're not going down that road. We're just gonna draw something. We know basically the shape of it. This is gonna be somewhere down in the negative region right here. Now, between negative 1/2 and 0, here's negative 1/2 and here's 0. It's saying we have to be in the positive region. So what you're gonna do is come from up here. You're picking up your 0. Everyone see that? Now, from 0 to 3, it's saying negative. So I really don't know how far down, but there is an asymptote here. So it's probably, I bet you it's gonna do something like this. That's my guess. Now, how accurate am I? I would have to plug in numbers like 1 and 2 to see how far down. And then from 3 to infinity, it's positive. So my guess is it's gonna be something like that. Remember, the asymptotes are more for the end behavior. So what's happening is this is getting closer and closer to x equals y equals 0. Yes?
Horizontal asymptote is 0, isn't it not supposed to touch the origin?
Yes, and we said it can cross in the middle. It can cross in the middle, but not at the end.
Alright.
And that's just strange. Okay, let's do the next one. Huh? Yeah, they're not. It's gonna take us 3 days to do this. All right. So, can everybody for me see this CV? No, don't cross it out. You need it. You're gonna write it above. Oh, okay. Cross it out here. That's fine. All right, so what are your critical values? What you're gonna do is you're gonna take your numerator and you're gonna factor it. Do you guys know what you get when you factor it? All right, give me all the critical important numbers. 2. It doesn't matter what order you put them in, -1 and 1. Okay, where do we put these numbers at? In your exclusion chart. Along with your factors. So we have, here's our factors. It's x, and it doesn't matter what order you put them in. X minus 2, x plus 1, and x minus 1. And then your grand finale, f of x. It's where you count. So now, right here, you're going to order them. You're going to put, why should I put -1 here? And why should I put 1 here? And why should I put 2 here?
Timeline.
Because you want to order them, because when you do, your exclusion chart, you understand if it's positive or negative.
Isn't it x minus 2? Isn't it -2?
So it's 2.
Oh, no, never mind.
Yeah, you set, to get the critical value, you set this equal to 0 and you get 2. Okay? All right, now, let's do this, let's fill this out while we're here. What's the magic number that will give you a 0 here?
2.
It's 2. So this is what I do, negative, 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 and that's a plus. How about this one? What's the magic number? -1. So negative, plus, plus, plus. Does everyone know what I'm really doing? I'm picking a number to the left of -1, and if I evaluate it, if I put -2 here, what's a -2 plus 1? It's a negative number. If I picked a number between here and here, like 0, if I put a 0 here, any number that you pick in between here and here is going to be positive. Are you with me?
Mm-hmm.
Okay, what about this one? I'm going to have a negative and a negative here and a positive positive, and a positive. So, let's count. 3 negatives,
Negative,
negative, 2,
Positive.
and it doesn't, everyone thinks it's always alternating. No, sometimes it doesn't. Sometimes it'll be a negative, positive, positive, negative. It could be a negative, negative, positive, positive. Most of the time, I'm gonna tell you, it's like this, checkerboard. Okay, everyone cool? Alright, let's go back up here. What are your roots? Your roots are where the numerator. So part of these are gonna be here. So it's 2 and negative 1. I want you right away, as soon as you do this, graph it. Put a dot at 2 and put a dot at negative 1. Because I know my graph has to go through these two numbers. These are the roots. The vertical asymptote, what is it gonna be? X equals 1. You set your denominator equal to 0 and solve. X is 1. I want you to put a dotted line at 1 right here. These are worth like 10 to 12 points each on your test.
It's really good.
Yeah, I know. I love it.
So
Okay,
the test is gonna be worth a lot of points.
like 40. I think I did
Four
like
question
4
test?
graphs. It takes, look at how long it takes to do 1 graph.
That's
4 graphs.
Yay.
Okay, which one of these 3 do we have? We have one of them.
Slant.
It's top heavy by 1, so there's a slant asymptote. It's one of these. So we don't have this and we don't have this. How do we find out what the slant asymptote is? What do we do? I'm gonna do synthetic division, because I can.
so, slant and synthetic.
Slant, you can only have a slant if the numerator, if the degree of the numerator is 1 more than the degree of the denominator.
I'm saying like, if you have slant, you use synthetic.
No. If I put a 2 here, or 3, or if, I could give you this problem. I could give you x cubed, blah, 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 x squared, blah, blah, blah. This is a slant asymptote, but you can't do synthetic division on this problem, because that has a 2 here. So let's finish this up. If we're lucky, 1 times 1 is 1, and we don't care about the rest. So y equals x is your slant asymptote. You better know how to graph y equals x, and that is this line right here. Okay? Your y-intercept, I'm going fast because I want to finish this. If you were to plug a 0 in here, what do you get? 0? Hurry up. 0?
0.
No? 0?
2.
2. Negative 2 over 1. Negative 1 is positive 2. So at 0, 2, you need to have a dot there. That's your y-intercept. And there are no holes, because we didn't cross any factors out. So now we get to graph this fun thing. So from negative infinity to negative 1, right here, here's from we want to be below the x-axis. Now, common sense, should I go in this region right here? Look at, should I be here or here? These are my 2 choices to be. Why here?
Because there's a dot.
Because I want to eventually cross this line. I can't cross it if I'm down here. So this is what your graph will look like. You're going to go down here. Then from negative 1 to 1, negative 1, here's 1. We want to be positive. So we're going to be pick this up, and go straight up. In the last part, from 1 to 2, it says negative.
He's gone.
He's gone.
He is gone.